It's 2025 paper 2 question 8. So we're basically told some information here. So it has a square base, and then here are the diagonals of the square. So you should remember from geometry that the diagonals of the square bisect each other. So they cut each other into the diagonals into half. And that this is going to be, these are all right angles here on the bottom square. So we're told to show that OB is 3 root 2. So what you kind of need to notice is that OB is going to be the exact same as OC, again, because of that bisection thing. So OB is equal to OC, we know that. And then we can use Pythagoras' theorem that OC squared plus OB squared will give us 6, because this is the hypotenuse, here's our right angle. And then since these are both the same, we can say 2OB squared is equal to 6. So that basically means, sorry, that should be 6 squared, so that should give us 36. So that should be 36. So that means OB squared is equal to 18. So OB is equal to the square root of 18, which is the square root of 9 times the square root of 2. So that's equal to 3 root 2, which is what they asked for. And then we're told to find OP. And the way that we can do that is then to find OP, we know what OB is, and we know what, for example, BP is, because they're all the same, they're 11. So there's another right angled triangle if you look at this one. So it's it's POB. It's kind of like that one. So basically, if we have P, O, and B, if I draw this triangle, completely not to scale, this distance here is 3 root 2. That's what we just found. The height is what we're looking for. That's OP. And then this is 11, because all of them are 11. It says BP is 11. So we can just use Pythagoras' theorem to say that 3 root 2 squared plus OP squared will give us 11 squared. So that means that OP, when you do this, will be the square root of 11 squared minus 18, because this is going to be 18. Bring it to the other side as a subtraction, 11 squared minus 18, and then square root both sides. And when you do that, what you get is the square root of 103. And just in case, you should say that distance is in meters. And same with the other one. But they kind of say it in the question, so you should have noticed that. But it's not too important. They're not too picky about units usually. Then we're told the angle PAB. So if we look at the triangle PAB, I'll draw it out down here. So here we have P, A, and B. AB is 6, these two sides are 11, and this angle here is 74.2. And we need to find the area of this triangle, and then we can just multiply it by 4, because we know that all 4 faces are the same. The 4 faces are congruent with each other. So if you're not sure what to do, you can split this into 2 right-angled triangles, and then this side is 3, and then you can figure out the area of this triangle and double it. Or you can just use the formula a half AB sine C, and it's important that the angle, the C, is in between the A and the B, according to this diagram. So the area will be equal to a half, and then we have 6 times 11, and then the angle between that will be sine, and we have 74.2. And then to get the total, we're basically just going to take that and multiply it by 4. So it'll be 4 times a half times 6 times 11 times sine of 74.2, and you can just multiply all those things together to get the total area. And when you do that and give it to the closest square meter, you should get 127, and then give your unit answer as meters squared. Then in part 3, we're given part of the net, and we're told to complete it. So this is a little bit difficult for me to do, but basically this triangle on the top is going to be folded down, and then this triangle on the right is going to go onto this side here. So we basically need to put a triangle on this side and this side. So what you'd have to do is you'd have to measure this length here with your compass. You could measure the angles, but that's a bit tricky. So if you just measure this distance with your compass, then what you can do is you can take that distance and draw a little arc starting at this point. I'll do it in red. So we can draw an arc coming out from here. So if I just approximately figure out what that is, the arc should look something like maybe like this. And then we also want the same distance to be on this side, on the bottom corner. So we'd go to the bottom corner and we draw an arc with the same distance. So it might look like this. And then where they intersect, obviously, is where the two distances, where the two circles kind of are equal. So then we can connect the intersection to here with a ruler, of course. And then connect the intersection to here. And they will both have the same distance because we used the compass to draw them. And the compass always had the same length. And then we just do the exact same thing down here. So we'll draw an arc kind of like this, and then we'll draw one out from here like this, and then where they intersect we draw the lines up, and that completes the net, because you can fold these two up and then this side gets folded over and then we're done. Then we're given a triangle and told to figure out percentage error. So we're looking for CAB. So let's just figure out what that is, the actual value, and then we can get the percentage error. So basically, if we want to get this angle here, we have the adjacent and we have the opposite. So we can say that tan of CAB will be equal to the opposite over the adjacent. So we'll have 17.5 over 15. Take the tan inverse on both sides. That'll get CAB is equal to, you'll get 49.3987. And we'll just round that up to 49.4 because it's very close to that. And we're told one decimal place anyway. So then to figure out the percentage error, well, the actual value was 50, or she measured 52. The actual value was 49.4. So let's figure out how much was she off by. So she will be off by 50 minus 49.4. Sorry, I should have said 52. The angle is 52. I just read that wrong. It should be 52 minus 49.4. So that's how much she was off by. And we want to see how much was she off by as a fraction of what the actual value was. So that's going to divide that by 49.4. So that's going to tell us how much she was off by as a percentage or as a fraction of the original value. And when you put that into your calculator and do one decimal place, you'll get 5.3%. So that'll be 0.053. Then we're given a little diagram. We're told to show that x is 25.5. So basically, we have this angle, but the corresponding side, the opposite side is here, so we can't really use that. It's not very useful. It would be useful if we could use this angle, because then we can use this side, which we know is 10 meters, and then we need to know this side, which is what we're trying to find, and then the opposite angle is this angle, so we need to know that as well. So basically, we can figure out, and you might want to give these labels. I don't know, I'll call this A, I'll call this B, and I'll call this C. So I can say that the angle CBA, well, it's going to be 180 minus 35. So if you do 180 minus 35, you will get 145 degrees. Okay, and we need to know that one because that's the angle that's opposite the x. So this is 145 degrees. And then to find, and I'll actually, yeah, I'll leave that one in red, and then I'll do this one up here in green. So then the angle ACB, well, when you add that to 22 and 145, that'll give you 180 because all the angles in a triangle add up to 180. So then subtract those things to the other side. We'll go 180 minus 145 minus 22. You get that ACB is equal to 13 degrees. Okay, so now we can use the sine rule. So it's 13 degrees. So basically, we're going to have 10, because that's the side down there. And when we divide that by sine of the angle opposite of it, which is 13, so 10 over sine 13 will be equal to, and then this side is x divided by, and then the sine of the angle opposite it is 145. So sine of 145. And you can just put that into your calculator. Well, you can solve for x first, I suppose. This makes it nicer. So x will be 10 sine 145 divided by sine of 13. And then you can figure out what that is. And you'll get 25.4978 ... And then that rounds to 25.5 meters if you do one decimal place. Then in part C, we're asked to find the total height of the marked H on the diagram. So it'll help us if we look at this pink triangle, because we know what X is, we know the angle, and then we need to figure out what H is. So I'm just going to call that ACD. So if you look at triangle ACD, we know that the hypotenuse is 25.5. We know this angle here is 22 degrees. And then this side here, be careful, it's not H, it's actually H without that 1.125, sorry. So it's going to be H minus 1.2, sorry, it is 1.25. It's going to be H minus 1.25 for that reason. So we know the opposite, the hypotenuse, so we can say that sine of 22 will be equal to H minus 1.25 over 25.5. Then you can just solve for H and get that H will be equal to 25.5 sine 22, and then add on to that 1.25, and you get your answer for H to be about 10.8 meters when you do it to one decimal place, which is indeed what they asked for.